So this is lesson 2.2 again. So we're going to solve inequalities. Solving inequalities is almost like solving an equation with one exception we'll get to in a minute. So here I want to get the x alone. So I'm going to subtract 5. So what does that give me? Let's see. 5 minus 5 is 0. 0 plus x is just x. I still have a greater than on the other side. 8 take away 5 is 3. So this says x should be greater than 3. So on the number line, 0, it looks like this is 1, 2, 3, 4, 5. So 1, 2, 3. 3 gets an open circle. And then greater than means I shade to the right. So that would be my solution on the number line. How do you check an inequality? Well, when you check an equation, there's only one number to check. How many possible numbers are there? Like there's infinitely many numbers that make this true. So what I usually do to check something like this, I pick a number on the left side, make sure it doesn't work. Pick the number on the boundary to make sure it's like an equation. And then I pick a number on the true side, make sure it's true. So just off to the side, I'm going to check to see if this is really true, and then I'm going to come back. So again, the equation is x plus 5 is greater than 8. A number that shouldn't work would be like x equals 0, right? Because x equals 0 is not in the shaded part. So in my check here, I'm going to check x equals 0. 0 plus 5 is 5. Is 5 greater than 8? That is false, which is good because 0 is not in the shaded part. So that's a check. X equals 3 is on the edge. 3 plus 5 is greater than 8. Is 8 greater than 8? Answer is no, that's false. On my number line, did I shade 3? Nope. It's where they match, right? So that's the edge. So that's okay. It should be false, but I should get the same number. And then a number on the other side, maybe x equals 10. 10 plus 5 is 15, which is greater than 8. That's true, which is good because it's in the shaded region. So these are all good results. So inequalities are more complicated because they indicate a huge range of numbers. And so the best idea is to test numbers, at least one number in the true region, at least one number in the false region, and then check the edge number to see if they have reasonable results. All right, so did you have to check this? The answer is no, but I just wanted to make sure you knew how to check one of these. Next one, 2x plus 5 equals 8. So to solve this, I would subtract 5. 5 minus 5 is 0. That's good. So I just have a 2x equals 8 minus 5 is 3. And then to get rid of a multiplication, we divide. 2 divided by 2 is 1x, or just x. And on the other side, 3 halves, that's an okay number. You could call it 1.5 if you plugged it into your calculator. I'm going to write 3 halves. I'm also going to write equals 1.5. Either one is an acceptable answer. On the number line, what do we got? This is 1, 2, 3, 4, 5. So it's right in between here. And it's an equal to, so it gets a shaded circle right in between there. So that right there is my x equals 3 halves. And again, because it's an equal to, there's no inequality, it's just a shaded, small shaded circle.
That's just a dot.
So just a dot, yeah. To the best of your ability around your 1.5 is. All right, this one solves the same way with a slightly different answer. We're going to subtract the 5. Fives are gone on the left, just the 2x is hanging out, less than or equal to 8 minus 5 is 3. Divide by 2 like before. So this time we get x is less than or equal to 3 halves. And again, 3 halves is the same as 1.5. So that is about here on the number line. And I want to be that number shaded or any number to the left because it's a less. And it would help if I read the directions. I missed a step. We want to solve each of the equations or inequalities, put your solution on a number line, and do interval notation. Forgot my interval notation. All right, so this one here, interval, the left side of the interval is 3. There is no right side, so it gets an infinity. Since it's not shaded, it's a parenthesis, and infinity is always a parenthesis. So that would be interval. Now, there really isn't an interval here. It's just a number. So it's not worth writing interval notation for just an equals. So there's really no interval here. So don't worry about that one. This one right here, the 1.5 is on the right. So that's got to go on the right side of the interval notation. The left side is forever. So that would be a negative infinity. Infinities always get parentheses. Since that circle is shaded, it gets a square bracket.
Would you accept 3/2?
Yeah, 3/2 is totally cool. Yeah. So that would be another answer. So you also could write negative infinity, comma, 3/2, square bracket, parenthesis like that. All right, so compound inequalities, basically it's really the same idea, but that -5 has to go on all 3 places. Is the only catch. We got to keep everything in balance. So each of the 3 places here has to get a -5. So balancing that, in the middle, the 2x is left. To the right, we have 8 minus 5, which is 3. 1, lose 5, -4, less than or equal to. The divide by 2 has to happen everywhere. So then here, we finally just get an x in the middle. We've got the 3 halves on the right side. And let's see, 2 goes to -4, -2 times, and it is the less than or equal to symbol. So let's see, -2 is right here. That gets a shaded circle. 3 halves is in the middle there between 1 and 2. That, oops, I did that wrong. That gets an open circle. And then I shade in between. Interval on that one, you got to keep them in order. So -2 is to the left of 3 halves. The shaded circle here is a square bracket. The open circle is a parenthesis. All right, so 1 is less than 2, true? -1 is less than 2, true. Right. It makes us feel better. We can write the little number line off to the side. And I'm going to pick on the -1 and the 2. Now, what I want to do is multiply both sides of the inequality by 3. So 1 times 3 is 3. 2 times 3 is 6. Is 3 less than 6? Yeah, it's true. Same thing over here. Multiply by 3, I get a -3. Multiply by 3, I get a +6. -3 is less than +6. Right? That's still true. So yes, they are still true. Okay, next we're going to multiply by -3 to see what happens. So back to the original, 1 is less than 2. 1 times -3 is -3. 2 times -3 is -6. Is that true? Here is -3. Nope, I lied. Let's put 0 in here. There's 0. If -3 is over here, where's -6?
That way.
Further this way. So like over here, maybe. Is -3 less than -6? No, it's bigger. So this is false. Similarly, check this one out. If I multiply by -3, -3 times -1 is +3. -3 times +2 is -6. 3, this says 3 is less than -6. Let's see, isn't 3 like way over here? No. -6 is way over there. This is false also. So here's the trick. Inequalities relate to the number line. When you multiply by a negative, you basically take what used to be on this side and you flip it over. You do a flip of the whole number line. And everything that was once to the right is now to the left, and it's backwards. Okay. So the moral of the story is anytime you multiply or divide by a negative number, you have to change the direction of the inequality because you just flipped the number line. Is the deal. So the above statements, are they still true? The answer is they are not true. If not, how could we make the statements true? We just flip the inequality. Flip inequality. So since if I want them to stay true, since I multiplied by a negative, I would have to write -3 is greater than -6 to make it true. To make this one true, I would have to state 3 is greater than -6. So either way, if I want it to be true, I got to flip the inequality. So what does this suggest about multiplying an inequality by a negative number? You must flip the inequality when you do that. When multiplying by negatives. You down there. So again, if you multiply by a negative number, you've got to flip the inequality after. And it turns out dividing by negatives, same idea. Multiplying or dividing by a negative, then flip the inequality. Doesn't matter for an equals, because if you flip an equals, it's still equal. Dividing by negative number? Yeah, multiplying or dividing by negative numbers. All right. So next part of this page. So this one does the same thing, but division. So we're going to get to see what I claimed is true in action. Pretty wrong button. Go. So in this case, we're asked to divide by -2. So if I divide by -2, 4 divided by -2 is -2, right? Positive over a negative is a negative. 8 divided by -2 is -4. And again, let's just double check this on a number line. If that's 0, -2 would be here, -4 would be there. And this clearly shows -2 is bigger because it's to the right. So the only way I can make that true is to state -2 is actually bigger, greater than -4. So is the inequality still true? Not true. How could we make the statement true? Flip the inequality. And if you copied my statement from above here and wrote multiply or divide, you could just write C above, otherwise rewrite the whole statement. So either you're going to say C above, oops, wrong C. Or if you didn't write or division up there in part C, You can just rewrite it down here. Bottom line, multiply or divide by a negative, you got to flip the inequality. And the last and final page. So similar to before, we want to solve the equation or inequality. We want to put it on a number line and give the interval notation. And then we're going to do one that was related to our tax problem the other day. All right, so now notice on each of these, you have the same kinds of numbers with a couple of alterations. And the way we solve them is pretty much the same. Since there's nothing to do on each side, I'm ready to start moving numbers around. So I'm going to move the 5 to the right with subtraction. That 5 minus 5 is 0, so that just leaves the 2x. 8 minus 5 is 3. To get rid of a multiplication, we divide by a negative. Negative 2 divided by negative 2 is 1. X is just x. And then on the other side, again, there's 3 ways you can write it. Positive over a negative is a negative. 3/2, which you could call negative 1.5 also. And again, if you flip an equals, it's still an equals, right? So the same rule kind of applies, but it doesn't matter. So here I would just go down to the number line, find negative 1.5. So that's negative 1, negative 2. So that would be about around right here. And let's see, it's an equal to, so that means it's a shaded circle right there. Is that a single number or an interval of numbers? It's a single, so there is no interval notation for this one. This is not an interval. So you don't need to write anything. All right, next one, same set of steps with one trick. Subtract the 5. 5 minus 5 is 0, leaving just the negative 2x on the left. On the other side, 8 minus 5 is 3. Now, subtracting a number is no big deal. Here's where it becomes a big deal. If you try to divide by a negative, what do I have to do next? Flip the inequality. So since I divided by a negative, I got to reverse that. Negative 2 over 2 is just x. And then this is negative 3/2. So again, that's also negative 1.5. So here's negative 1, negative 2. So right in the middle here, my negative 1.5. And this says x can be any number greater than that. So this time I get an open circle there and then shade to the right because it's greater. Interval notation for that, I'm going to write underneath here. Negative 1.5 is on the left, so that has to be the left side of the interval. So negative 1.5. And it's not shaded, so it's a parenthesis. What's to the right? An infinity. And infinity always gets a parenthesis. The only way to check an inequality like this is you have to check a number to make sure it's false, the number on the edge, and then check a number in the true region. Okay, I'm going to skip that for now. But again, to check this, you really would have to check 3 numbers to make sure you're on the right track. Next, almost the same, but I have a double inequality. So when I minus the 5, it has to go from all 3 places. So let's see, 1 take away 5 is a negative 4. Here, the 5s cancel, leaving just the negative 2x. And then over here, 8 minus 5, we determined was 3. And for now, since we just did a subtraction, the inequalities stay the same. So less than, less than. To get rid of the multiplication, we have to divide. And since the number we're dividing by is negative, in the next step, I got to flip those inequalities.
You flip both of them?
You have to flip both of them, yeah. So it's going to go, instead of a less than, that's going to turn greater than, and greater than. Negative divided by negative is a positive. 4/2 is 2. Negative 2 over negative 2 is 1, x. And then this is negative 1.5. Now remember I said with double inequalities, you got to read from the variable. So this says x is less than 2 and x is greater than negative 1.5. Those numbers are backwards, aren't they? Because when you put them on the number line, the 2 is over here. And the negative 1.5 is where? Negative 1, negative 2 right here. Negative 3/2 or negative 1.5. They both get open circles, open circles, and then shade in between.
Wait, why do they both?
Because it's not an or equal to. It's just a less than or a greater than. So the interval for that would be negative 3/2 on one side, 2 on the right. You got to put them in numerical order, Garrett.
So the less than or equal to thing flips when you switch from multiplication to division.
If you multiply or divide by a negative, if it was a less than or equal to, it would become a greater than or equal to.
Okay, so
Yeah.
when you multiply by negative is when it switches.
Yeah. Yeah. And again, we have to keep these in order like on the number line, and they each get a parenthesis because the circles are not shaded, right? They're open circles. Now, again, this interval up here is bugging me because negative 1.5 should be on the left. So I would rather write it. There's nothing wrong with this. This is true. But I'd rather write it negative 1.5 on that side and 2 on that side with x in the middle. Now, again, look at how I read this. This says x is less than 2. So down here, it has to go that way to stay less than. This one here says x is greater than negative 1.5. So I'd have to write it that way down here. Okay, so if I reverse the numbers, I got to reverse the inequality so it reads properly. Okay, this is okay. That's fine. It just bothers me because the numbers aren't in numerical order. But there's nothing wrong with it. You could leave that red answer there. I just prefer to write it like it appears on the number line. Questions? Not too bad. All right. All right, moving on. One more problem, I think. Yeah. All right, so let me get a screenshot of this so I can scribble on it. Add to page, please. All right, so think back to our tax calculation formula. We know the formula we used was valid when X, which is the taxable income, was between $9,075 and $36,900. We made that calculation yesterday in class or the other day in class. For a single person with only wage income, taxable income is wage income minus $10,150. So X, the taxable income is the wage income minus 10,000. That's for a single person. We did it with a couple, which was what, minus 20,000 in class the other day. So what we want to do is we want to substitute. So again, check it out. Here they're saying X is equal to that right there. Substituting this into that inequality there, we get this new one. And they want us to solve this inequality. Okay, that shouldn't be too bad. I'm just going to rewrite it. So 9,075 less than W minus 10,150 less than or equal to 36,900. To solve something like this here, we just need to get rid of the minus 10,150. What do we do to get rid of it? Add it everywhere, yeah. So you add it in the middle and add it on the left and add it on the right. So 10150, add that. 0150, add it there. So what do we get when we clean this up? W should be the only thing in the middle now. That's going to be 5,229. I'm getting 19,225. Anyone else?
Yeah.
Okay. On the other side, what do we get? 0, 5, 9 and 1 is 10. 6 and 1 is 7, 3 and 1 is 47,050. Cool. So this
Yeah.
tells us that the tax formula we were using before for people in that middle tax bracket would have a wage income between 19,000 and 47,000 roughly. Could it be exactly 19,225 to use the formula? The answer is no, because there's none or equal to, but it could be exactly 47,050 because there is an equal to there. One more step. Interval notation. Smaller number goes first. And I'm not going to use commas. 19225, because the interval has a comma. 4750. The or equal to here is a square bracket, and then the not or equal to is a parenthesis. So that would be the interval version of a solution. Rock on. We did it. Congratulations. Done with the most boring lesson ever. It'll get
Oh,
more
man.
fun next class. Promise.